Welcome back everyone. In today's video, we will see how to find the solution of a differential equation where we have n independent variables. Okay. Earlier, what we used to do is that we used to have z as dependent and it was a function of let us say phi of x comma y, phi of x comma y. But now we can have a function phi which will be x1 comma x2 comma x3 comma x4 up to xn, which will be some u. Okay. And if we have to solve this linear partial differential equation, which has n independent variables, we will just expand the Lagrange's equation that we used to write for two or three variables. Okay, what we used to write there? It used to be dx by p equals to dy by q equals to dz by r. Okay, similarly, now what we will write is that du by let us say r equals to dx1 by p1 equals to dx2 by p2 equal to dx3 by p3 and so on. I know it is a little difficult to understand when I'm writing in this way. We will understand it better through an example. Okay. Today I have a sore throat, so just bear with me. Sorry. Now, let us say we are given this particular example, like x dou u by dou x plus y dou u by dou y plus z dou u by dou z equals to some xyz. Now, if you see here, earlier what we used to have is that p into p plus some q into q equals to r, correct? But if we take this as p, this as q, still we have something left here. So here we have three independent variables. Okay, and our dependent variable is u. So here we have u as a function of x comma y comma z. Okay, so here the Lagrange's equation that we used to write earlier, we will expand it as dx by p equals to dy by let us say p1, dy by p2, dz by p3 equals to some du by r. And now you will ask what is this p1, p2, p3 and r. If we write this given equation in the form of some p1 into let us say some p plus what shall I say? Let us say this is right du by dou u by dou x. What shall we take? Let us say lambda 1. Okay. Then dou u by dou y. Let us take it as lambda 2 and so on. Dou u by dou z equal to lambda 3. Then we will write this as p lambda 1, p1 lambda 1 plus p2 lambda 2 plus p3 lambda 3 equal to r. Okay. Here p1 is x, p2 is this y, this p3 is this z, and r is this xyz. Okay. Now see dx by x, dy by y, dz by z, and dou u by or du by xyz. Clear till here? Once we write this, the solution part is the same as we used to do earlier. Just that earlier we used to have two independent variables, and hence we used to get two constants. Correct? Now here we have three independent variables x, y, z. Hence, obviously, we are going to have three arbitrary constants. So now let us take first these two and solve. Dx by x equal to dy by y. If we integrate on both sides, we'll get log x minus log y equal to some log c1. I've written here ln, but it should be log. Okay. Now x by y equal to c1. Now don't ask how x by y equals c1. We have done it multiple times. It is just that ln a minus ln b. It is ln x by y equals to ln c1. So x by y equals to c1. Okay. Now if you take ratio, these two, same process, integrate them, and we will get y by z equal to c2. Now if you observe, here we have x by y equal to c1. So let us say x equal to y c1. And here let us take y equal to c2 into z. Mm, correct. Let us take x equal to y into c1 and y equal to c2 into z. So these two values we will replace here. What will we get? Du by x was our c1 into y. This y as it is. Mm, and this z. We will get it as du by c1 y square z. Okay. Now we know that this particular y we can write it as c2 into z. Okay. So du upon c1 into c2 z whole square into z. So here we will get c1 c2 square into z cube. Okay. Now once we have solved this, we will write dz by z equals to du by, means we are taking this ratio and this ratio. Here directly this z gets cancelled out for z cube and we are left with z square. So c1 c2 z square dz equals to du. Now once we have these two, just integrate on both sides. This is a constant. So as it is, z square integration, it will be z cube by 3 equals to u plus some c3. Okay. So what we will get just by rearranging is that c1 c2 square z square, sorry, z cube minus this 3 will go here. 3 equals to, here let us take it was c3 dash. Now here it will be 3c3 dash. Once you multiply with 3, and this 3c3 dash I have taken as c3. Okay. Now replace back the value of c1 and c2. This is what we will get. Simplifying, we get xyz minus 3 equal to c3. And now, like earlier, how we used to write the final solution? Phi of c1 comma c2 equals to 0. Right? Now here we have three independent variables. So we'll write phi of c1 comma c2 comma c3 equals to 0. And this is our final answer. Okay. Thank you.